Hello and welcome to Quadratics with Dundee. So first of all, what are quadratic functions? Well, they're functions with x with the greatest degree of 2. You can write this in three forms. Standard, y equals to ax squared plus bx plus c. Vertex form, y equals positive or negative to absolute value of a times x minus h squared plus k. And factored form, which is y equals ax plus c times ax plus d. All this together draws a parabola, which is like a curved U shape. Your first question may be, how do we graph this weird shape? Well, I'm here to explain this to you with two methods. The first method is to create a table of values. We start off by creating our table. The first column on the table is for the x values, and the second column is for the y values. For this, you just input x and solve for y, substituting x in the equation. Our example today is x equals to negative 2 distributed to x plus 1 squared and subtracting 3 from the sum. So, when we fill our x value column with values negative 3, negative 2, negative 1, 0, and 1, you would get negative 11, negative 5, negative 3, negative 5, and negative 11 respectively. To show you how we got this, I showed the complete steps of when x is equal to negative 1 in light green. It should be located beside a green star. You can find it directly below the table. After we have our table filled out, we can now plot our points on the graph and connect them together to create the parabola. When drawing, don't forget the arrows and please label the equation. And boom, you're done. Time to show you method 2. Method 2 is just showing step-by-step translations and transformations. The example I will use for this one is negative 1 over 2 distributed to x minus 2 squared and adding 2 to the sum. We started transformations at y equals to x squared. This is shown in orange on the graph. The first thing we do is to see negative 1 is multiplied to our absolute value of a, which is 1 over 2. So we first reflect the parabola over the x-axis vertically. Then we can compress the parabola vertically by a factor of 2. This is done by dividing every y value by 2 and using those values. Now we can look at our h and k values. Our h value is 2, which means we shift the parabola horizontally to the right by 2. Then our k value is 2, which means we shift the parabola vertically up by 2. And after you did those steps, you should label your graph and draw arrows on the parabola, and that is the entirety of method 2. Now that you know how to graph parabolas, you may wonder, what are the different properties of the parabola? Well, you came to the right video. There are 6 different main properties of the parabola. Firstly, there's the direction of opening. This is when the parabola is a U-shape or lowercase n shape. When it is a U-shape, it is an upwards opening parabola, and when it's the latter, it is downwards opening. The example for method 2 opens downwards. Secondly, there is the vertex. The vertex is the highest or lowest point of the graph depending on the direction of opening. If it opens upwards, it is the lowest point, and when it opens downwards, it is the highest point. In our example, it is the point 2, 2. Thirdly, there is an optimal value, also known as a minimum/maximum value. This is the y value of the vertex, with the highest or lowest point y value. In this example we have, it is y equals to 2. Fourthly, there's the axis of symmetry. This is the horizontal center of the parabola, with the x value of the vertex. For this parabola, the axis of symmetry is x equals to 2. Fifth, we have the zeros, also known as x-intercepts. These are x-intercepts of the graphs, which happen when y is 0. In our examples, the x-intercepts are 0 and 4. Finally, there's y-intercepts. Our y-intercepts are the y-intercepts of the graph. This happens when x is 0. In this example, our y-intercept is 0. You can also put what the y and x-intercepts are in between if you do not know the exact values. Thank you for watching my presentation.